what we do, so we'll kind of build up to the more complicated ones. We first focus on the numbers. All right, so we're looking for the largest number that divides evenly into 24 and 36. All right, that's a pretty easy one. You should be able to do that in your head. If not, that's okay. You have the calculator. All right, so type it in. Oh, whoa, what happened there? That's new. What on earth? What? Never experienced that before. All right, so GCD 24, 36, you get your 12 that way. All right, so we look at the 12 as part of the GCF. It might be entirely the GCF once we account for the variables. All right, so what I would look at are the two terms. I have a y to the first and an x to the first. All right, that means they're only happening one time apiece. So I would go across the line assuming that the variable is in each term and choose the one with the lower power. The problem is the variable is not in each variable is not in each term. All right, so there is no x in common. There's no x in this expression. There's no y in this expression. So we're actually not going to be able to pull out, we're not going to be able to factor out a variable here. So what we do is we take our 24y minus 36x, divide each part of that by the GCF, and we place the GCF out in front of the resulting expression. So I'd look at this and say, okay, well, what is 24 divided by 12? That would be 2. Bring the y along for the ride. Minus comes along for the ride. 36 divided by 12, that would be 3. X comes along for the ride. This final expression would be the answer, because if you distribute this out, so you take this answer and make it a question in Unit 5, distribute it out, you would get 24y minus 36x. All right. But then you look at number 6 right below it, and you see it's definitely more complicated. You got more terms, but numerically it's a little bit easier. All right, because I look at the numbers first. Across the board, I see 5s. Some are negative, but each one of those values would be divisible by 5. That's a really nice characteristic of this problem. But then I see that the m is represented in each monomial. So I know I'm going to have a m. It's the GCF, the C part, the common, has to be common to all terms. We have 3 terms here. If there's an m missing from any of the terms, then it's not part of the GCF. All right. So then what I would do, I have my m, I just grab the lowest power and make that the power of the m in my GCF. All right. And the justification for that has everything to do with expanding the whole thing out. I'd write 4 m's, 3 m's, and 2 m's and say, well, how many are in common across all 3 sets? Only 2 m's. All right. Multiplied, of course. So then what I would do is take each term and divide it by the 5m squared, the GCF. Five m squared will become the multiplier of that result. We go by the numbers first. Negative 5 divided by 5, negative 1. To account for the variables, I mean, you could do it by expansion. That gets pretty tedious pretty quickly. But I'll show you just the one time. That would be m by m by m by m divided by m by m. So you'd say, all right, let's get rid of m divided by m is 1. Another m divided by m is 1. you'd be left with m times m, which would be m squared. But a more convenient way of doing that would be just subtracting the exponents. All right. When you multiply monomials, you keep the base and add the exponents. So it would make sense that if you divide, you do the opposite operation. Division is opposite of multiplication. Subtraction is opposite of addition. So subtract the exponents. All right. Another negative 5 divided by 5. Oops, a little too dark there. Gives you a negative 1. Keep the base, subtract your exponents. 3 minus 2 is going to be 1, so m to the first power. You just leave that power of 1 off if you want. All right. Now the last part of it doesn't require any complicated math. You're looking at two identical values that are being divided. Anytime you divide something by itself, the result is equal to 1. Doesn't matter how complicated it is. Anything divided by itself is 1. All right. But you can carry it out too. You could say, all right, what is 5 divided by 5? That's your 1. Keep the base, subtract your exponents. All right. 2 minus 2 is 0. M to the 0th power. Well, anything to the 0th power is going to be equal to 1. All right. So 1 times 1 will give you a 1. So you could get it by using the process, but you could also get it just by using, I'll call it common sense, but it's more like just having algebra sense. All right. The last one that I wanted to do is number 9. We have 10 h to the third n to the, so basically two variables. All right. So the way we handle it is the same way we handle all the other problems. Go by the numbers first, GCF. We have 3 values here, the 10, the 2, and the 14. Doesn't take a whole heck of a lot of thought before you realize what the GCF ought to be. But let me just show you how you handle 3 terms in a calculator. And it's really pretty simple, but it can get tedious. You just do them 2 at a time. All right. So the way we would handle this is by doing GCD of the 10 and 2. That'll give you the 2, coincidentally. And then take that answer and GCD it against the remaining number. All right. So whatever the answer is of the first computation gets compared against the remaining digit or value. It's not necessarily a single digit. All right. So then I would type in 2, 14, and I would get a 2 as a result. All right. Same idea with the TI. Math, NUM, option 9. Type in the 10 and the 2. Then take that 2, math, NUM, option 9, and compare it against the 14. And you see that it's a 2. But, again, you're looking at it and saying, all right, what's the largest number that divides evenly into 10, 2, and 14? You start off with the fact that they're even, so you're thinking 2. So then you increase from there and you say, okay, well, what about 3? Well, 3 is bigger than 2. If I try to divide 2 by 3, I'm going to get a fraction. In fact, if I divide 2 by anything bigger than 2, I'm going to get a fraction. All right, so we know that it would have to be maxed out at 2 anyway. All right. The GCF, numerically, can't be bigger than the smallest number in your set. All right, so once you pass, or once you get to the smallest number in your set, then you're done. You found it. All right, or hopefully you found it. Otherwise, you made a mistake somewhere. All right, so we know that there's a 2 in our GCF. Now for the letters. First, I'm going to verify that in each term, I have an H and an N. At least one H and at least one N. All right. If I'm not sure, I go through and I start tucking in powers. But basically, if you see the letter there, it's there. I suppose it could be a trick where they put an H to the 0th there, but you could still even consider that as having an H. It just wouldn't really be meaningful. All right. So what I do is I replicate the H and the N. I go across the line and I look for the lowest power for H. The lowest power here appears to be a 1. I look for the lowest power for n across the line. I got a 3, a 2, and a 1. So the lowest power is the number 1. So my GCF is 2hn. So I now have to divide each term by that 2hn. If you organize your work, reasonably, then you could save yourself some of the writing. Like, for example, I'm doing this for instructional purposes, but if I were doing this on my own, I would do my GCF. I would do that off on the side here so that I could do the division right off of the original problem. Little things like that cut down the amount of work that you have to show. All right, so 2hn multiplied by whatever the result is of this computation. 10 divided by 2 gives you a 5. Now, we got to remember that each of these hns is really h to the first power, n to the first power. All right. For the h's, we keep the base and subtract the exponents. So 3 minus 1, h squared. 3 minus 1, n squared. Subtraction. 2 divided by 2 is going to be a 1. You don't have to write the 1 if you don't want to. 1 minus 1 is 0. So that would be h to the 0th power. Anything to the 0th power is equal to 1. Right? So I don't have to write that either. Right? So the only relevant piece here is the n squared divided by n to the first. Keep the base, subtract the exponents, n to the first, or just n. Bring down the plus. 14 divided by 2 is 7. Keep the base, subtract the exponents for h. You get h to the 0th, which is 1. Keep the base, subtract the exponents for n. You get n to the 0th, which is also 1. So this would be, if we wrote out every little detail, this would be 7 times 1 times 1, which is ultimately just a 7. All right, so I'm not going to write any of that. I'm just going to leave it as this. And this would be my final answer. All right. Now, it is possible that you come up with a common factor, but not the greatest common factor. If that happens, there may be more factoring that you can do with the in this case, trinomial or the polynomial that remains. But if you choose the greatest common factor, then you won't have to worry about that. So, yeah, sure. All right, so you're on the hook for pages 2 and 3. So try those problems between today and tomorrow. The normal homework rules apply. Yeah, just try a good variety of problems. You don't have to do every single one of them, but try a good variety. As long as you touch on all the big ideas, you're good. All right, but you got the rest of the class to bang that out, or at least get started on it.